Welcome everyone to Displacement and Settlement Monitoring, how Kurloo is making it simpler and more effective. I'm Melissa from Kurloo, and we're so pleased to have you with us from all over Australia and the world. So thank you for joining us. Firstly, we'd like to acknowledge the traditional custodians of the lands that we're speaking to you from today, and we pay our respects to the Turrbal and Yuggera people, acknowledging elders past, present, and emerging. We extend our acknowledgement to the traditional owners of the lands on which you're on, wherever you're joining us from today. The bushstone curlew is a native bird from these lands and is commonly found across central and northern Australia. And it's the inspiration for the name of our company. So here's our agenda for the next half hour or so. Firstly, we're going to cover why remote monitoring is a conversation worth having now. Then we'll talk about some of the current solutions available, their limitations, and the opportunity that we saw for Kurloo. We'll then dive into 4 case studies of Kurloo remotely monitoring across different applications. You can use the Q&A function to drop any questions you have at any time, and we'll make sure we try and answer those throughout the webinar. So now I'd like to introduce you to Lee Helen, CEO and founder of Kurloo Technology. Lee is a registered surveyor and geospatial expert with over 25 years experience. He's an award-winning leader, a respected innovator, and has led industry research collaborations with several Australian research partners since 2018. Kurloo is the result of one such successful research collaboration, which he'll share with you today. So over to you, Lee.
Thank you, Melissa, and thank you for everyone joining us today on our webinar. I'm going to start our webinar today just with this first slide. I'm just going to talk for a couple of minutes with you around this project and why this became an inspiration for us for Kurloo Technology. This slide was taken back in 2017, and it was the site of a very large embankment. Our customer approached our company to precisely monitor the slope which these points are located upon, and to alert them as soon as they recorded greater than 10 millimeters of displacement at any point in time. This was an opportunity for us to cut our teeth on satellite positioning technologies, particularly for monitoring applications and slopes. In this instance, this technology was ideally suited for this application, purely for, as you can see, the very large distances and the size of this embankment that we needed to measure. It was also quite unsafe for our personnel to be accessing this site on a frequent basis. And it required us to look at a different way with technology, and this is where we adopted satellite positioning as a method. So in this instance, we observed this embankment for a period of time and created an automated alerting system to notify both the contractors and the project managers of precisely when this embankment moved over time. For us, this was quite a complex challenge to solve. We utilised the equipment that we used was quite expensive. These are precise GNSS, continuous GNSS operating technology. And as you can see, very rough terrain, very difficult to install. And the whole installation took us around a day and a half to install the equipment. And it was a very expensive solution. However, it met the needs of the customer, and the customer was satisfied, except it wasn't economically viable to maintain for a long period of time. So what we went away from this project with a lot of learnings. This project was the inspiration for us to create a far simpler, more cost-effective method to use space-based or satellite-based positioning technology to monitor slopes. And as we did our research in this field, it's actually quite a common application. If you look at typically tailings dams, civil subdivision works, landslides, generally very large embankments for traffic corridors, highways, railways, even buildings and land reclamation that we use for ports and airports. They all have a common need to be able to measure displacement or movement over time of these assets. And particularly over quite large areas, satellite positioning is a very suitable and economical method for achieving that. I'd like to just focus for the next minute or two just going through this slide, which really, I suppose, explains a little bit about the motivations of why we monitor. And I'll explain why particularly continuous monitoring is driving smarter, more efficient ways of working. What we see quite often on the left is there's a number of variables that we face in our practice today, many of which are very difficult to control. We have generally increasing public expectations, increasing numbers of aging legacy assets, so the number of assets that we have to monitor is increasing over time. And we're also having to continuously improve our safety through remote operation. There's also a lack of availability of highly skilled labour. We're dealing with more frequent extremes of weather and greater adoption of data-led decision-making and machine learning. It's extremely difficult to manage variables that are very difficult to control. And this is where we believe the modernisation of codes of practice and standards and technology is assisting us not just to manage our assets, but to provide a level of leadership in the way that we control and operate our assets. What's also very important is we are responsible for the way that those assets are managed. That responsibility, as I said, requires a level of leadership, but also because, as we said, it's very difficult to manage variables that are out of your control. So this is where adopting new technologies are helping us drive a more effective outcome through driving smarter and more efficient ways of working. So after our research on the embankment in early 2017, we really saw that the application or the need to come up with a smarter technology, a more efficient technology to continuously manage or measure particularly large infrastructure. There was a real need in the marketplace for this, and we found out that what we did was we assembled a team, a band of gypsies here on the left-hand side in 2018, and this team comprised of leading researchers both in geodetic and the positioning space. It comprised of industrial designers, manufacturers, software engineers, and we actually then, I suppose, fleshed out the idea of what if we could create a very simple to deploy, low cost positioning service that was able to assist asset owners, engineers, contractors to give them a degree of leadership in their decision making, to be more informed about the way they made decisions, and allow them to have a better way of managing responsibility in the way they operate their works, their assets, and their projects. So we were successful in 2018 in securing a grant with the Australian Department of Industry, Science and Resources through the Innovative Manufacturing CRC to actually design and manufacture a smart positioning device and service. And we collaborated with the leading researchers from the Queensland University of Technology to achieve this. And in 2022, in May, we actually launched our product. This was achieved during COVID-19. It was a tribute to our team to not only to be able to complete all the design and testing and development, but also successfully launch the product. So what have we created with Kurloo? We've created what we believe is as a service that allows you to achieve millimetre precision more simply and economically than ever before. One of the features of the positioning service we offer is our Kurloo device. This Kurloo device uses satellite positioning, so includes precise antennas and receivers inside the unit. It's also completely sustainable and self-sufficient. So our unit generates its own energy through a solar panel on the front of the unit and stores that energy for up to 14 days worth of operation without charge. We've also incorporated a number of intelligent sensors in the device to allow us to sense and control the device completely remotely without any human intervention. The device automatically then records data on a daily basis, and that gets transmitted to our cloud computing processing service, which then takes the raw data from the devices and then refines that into a very accurate position, generally within 0 to 3 millimetres of relative displacement on a daily basis. That information is then very simply displayed and interacted with the customer via our Kurloo Nest platform, which is our offline web service that allows you to display results, integrate with rainfall data, and do some basic analysis of rate of change of different points over time, create and set customized alerts when certain tolerances have been exceeded, and also set up automatic reporting that can be either sent directly to your email inbox or to a specific computer server that you have. So we've tried to, as I said, we've achieved a way of receiving millimetre precision of your asset in a very simple and effective way. So that's, Melissa, we might just take a little break in proceedings there for everyone to digest how we invented Kurloo. Melissa, would you like to conduct a quick poll for us?
Yeah, yep, I've just activated the poll. It's a good chance for us to get a bit of a sense check on what challenges everyone's facing. So you'll see that poll in the left-hand panel if you'd like to participate, and just let us know which of those is your top challenge, and I'll publish the results of those a little bit further down the track.
Okay, thanks, Melissa. So, and if you've also got any questions you'd like to answer at the end of the webinar, please insert them in the chat and we'd be happy to answer them for you at the end of our case studies. So the first case study I'd like to share with you is a slope stability public safety application that we conducted for a period of 16 months. And this case study is at Froggy's Beach on the Gold Coast, which is a popular beach in Queensland, Australia. And this slope here has experienced some significant ductile creep in the hill above the beach, which you can see ahead of you here. The cracking and movement became evident along the footpath at the top of this cliff, and the movement is observed in the boardwalk that runs down to the beach. So the problem for the local government here, that disruptions in this location not only were a public safety risk, but they also negatively impacted on local events and the enjoyment of this iconic public space and the nearby historically significant area. And it was hypothesised by the council that the increased sea levels and large low pressure weather systems systematically was washing away the material at the toe of the slope that you can see here, and it's allowing the slope to slide progressively over time. And together with the geotechnical consultants Butler Partners, they recommended that we put Kurloo through its try Kurloo on this slope as a non-intrusive and cost-effective way to understand how this slope was performing over time. So you can see the location of the sensors that were placed on this slope. And here's a chart showing the displacement of these two sensors over time on the embankment. So in the top right-hand corner and the Kurloo nest, you can see the direction of the displacement. And natively, Kurloo gives you a three-dimensional displacement is a very powerful measure of movement, purely because it gives you both the direction and also the magnitude of the displacement that you're encountering. So as you can see on the y-axis, you see the displacement magnitude, and on the x-axis is time. And in grey, you can see there the overlay of the Bureau of Meteorology data that was taken with a similar timestamp. So very interestingly here, we've got a very clear trend that occurs on this slope, is that once we exceed around 50 to 60 millimeters of rain, you get this accelerated displacement of the slope, in some cases up to about 35 millimeters. And the advantage of Kurloo is obviously these displacements are quite often not visible. This sensor technology is the only way to actually quantify exactly how far the slope is moving. So you can see there's a definite correlation between rainfall and displacement, but more interestingly for the geotechnical engineers was the amount of contraction or that happened after we had significant rainfall events. So you're seeing this cycle here on this embankment where you get a significant displacement, and then over time the slope, there's a contraction. So essentially almost like back up the slope, which in fact is probably more of a problem for the boulders. So as the contraction occurs, the stability of those boulders that sits on that slope is compromised. So, so this was a very useful, this gave some incredibly powerful insights for both the geotechnical engineers and council, so they could more accurately estimate exactly how much displacement would occur in each location after a rainfall event, and then plan a maintenance regime to say that they would expect after X number of significant rainfall events, the likelihood of a boulder displacement would be X, which then led them to some staged or planned remedial work to remove those boulders, them knowing having a far greater understanding of the behaviour of the slope. Just interestingly, just as a comparison, if you were to use, say, a conventional reading once every 3 months, that whole insight around expansion and contraction or displacement and then contraction would not be realised. So this is another insight this is another benefit of being able to measure much more frequently and aligning that to activity on the site, be it rainfall, be it other activities, is that you can actually gain greater insight into the true characteristics of how that slope performs, rather than just getting a interim shot, which may actually tell you the overall displacement, but you would lose some of that interim information around contraction, which wouldn't be evident from conventional measurements. And in the words of the customer, with Kurloo, we have a new tool to quantify and manage risk at a more sensible cost. And as our client Butler Partners outlined, generally they would only act upon these types of events once we saw some sort of visible impact. And now they have a way of providing clients with a quantitative risk assessment as opposed to just qualitative. And as consultants, their reputation is elevated by being able to get in front of their clients with new technologies, and obviously to save them time, money, and improve safety. So that's our first case study for today around slope stability. I'd like to share a second case study today around another slope stability application, but this time on a legacy railway line. And you can see the railway line here prior to the commencement of Kurloo. Several years prior, there was some remediation work done to this section of track. So it was a known area of concern. And we very quickly and simply, in a matter of hours, an hour and a half, we deployed these Kurloo sensors to this embankment. This was a benefit, obviously, for the rail operator, is that it minimised the time that they had a closure on the track. So to be able to actually deploy this technology very quickly and simply is a great advantage to them. And here you can see the results of the monitoring of this embankment over a 16-month period. So again, top right-hand corner, you can see the direction displacement. You'll see the top sensor 003 is experiencing greater levels of displacement. However, it was highly likely when that sensor was installed, there was a small channel where rainfall used to flow, and you can see the direction is not quite logical on the sensor, which is probably attributable to just the monument or the simplicity of the monument that was installed in that location. But again, this chart was very, very useful for the rail operator. As I said, what it did give the rail operator is during these really significant rainfall events, which you can see some of those towers in the middle of the data, it actually gave them a high degree of confidence that the embankment was performing as it does normally. As I said, even though there is some displacement, we're talking about 10 to 15 millimeters of displacement over a period of 18 months, or 1 millimeter a year. And they're particularly looking for that, sudden changes within that. So you can see a small spike in July, and it's when those spikes generally occurred is that Queensland Rail, again, they could quantify exactly what that displacement is, and then they could have a response that was proportionate to the amount of quantitative measure. So again, previously for the rail operator, it was a visual inspection. Now with Kurloo, they have the ability to actually quantify those movements and lead to further geotechnical investigation if required. So as I said, in the words of this client, Kurloo enabled them to remotely monitor progressive and accelerated movement. And as I said, they experienced some significant flood events during the year where they were unable to access the track. So remote monitoring was very, very useful in that instance. And Kurloo gave them the confidence in the embankment stability at the site during these times. In the shorter term, this technology enables them to monitor movement of the slope using rainfall and also have automated alerts. But also it gives them the ability to alert for higher risk of failure. And this, for more importantly, for the rail operator, is this informs them when inspections are required and when they should be closing the track, and also possibly planning out more significant maintenance to occur. Our third case study for today is around settlement and land reclamation. And in this case study, we simply installed Kurloo, as you can see in the previous slide, to a number of settlement plates in a settlement paddock here at the Port of Brisbane. So as I said, these sites are very can be quite busy sites. Generally, there's a lot of machinery moving around, and it's not really the environment where ideally you have surveyors running around taking settlement plate measurements. At the moment, that's the incumbent solution. There's no way that we can achieve the precisions that they need for the geotechnical analysis. So generally, we measure less frequently, and quite often there's quite a degree of inconsistency in these settlement plate readings from time to time. So we deployed Kurloo over a period, over an extended period. So you can see here that we've essentially monitored for nearly 12 months, and we automated the, I suppose, the settlement readings that were recorded on each plate. So the benefit of this case study for our customer is it's certainly assisting the Port of Brisbane with further empowering them with remote operation, which makes their operations safer, more consistent with the more frequent measurements they receive from Kurloo. And essentially it's delivering insights that they can act on quicker than they could with the confidence that the data they have is accurate. So rather than waiting for a number of weeks to be certain about a data and a settlement trend, they can actually get that insight far sooner by taking more frequent measurements. And that's obviously got efficiency and cost benefits for the Port of Brisbane by being able to have a reliable data source like Kurloo as early on as possible in the sequence. And they've made the comment how surprised how easy Kurloo is to install and operate on the Kurloo Nest platform. And our final case study today is with a contractor. This is hall contracting around some earthworks or a contracting assignment they had to increase the height of a seawall. So as you can see in this diagram, we progressively, the contractor here was asked to increase, bring in additional rock and build up the height of the seawall over time. This is, and this was a particularly challenging environment for having personnel working. As you can see, very rough ground. It's a very isolated site. So this is a very, very large area. And obviously there's not a lot of room with machinery moving constantly in this area. So actually the ability to take frequent measurements is quite difficult, not just from a technical perspective, the precise measurements of a survey, but also, you know, not having people go out into that environment frequently is an ongoing risk that needs to be managed by the contractor on a frequent basis. So you can see in this instance, progressively as the rock was placed, Kurloo sensors were added to the settlement plates that we're using to progress to measure the performance of the works. And this was very useful, as you can see, for the contractor, knowing that their works were stable, there wasn't any chance of collapse, or that in some way that their contractual arrangements were being met progressively rather than, and they could know while they were in the area if there was any additional work required. So you can see the displacement in position of the rocks over time didn't exceed, and that's in a 6-month period, just over 6-month period. The accuracies there of, you know, sub 20 millimeters was a very good result. And also, not only because Kurloo is native 3D observation, we could also tell the settlement rates of the rock, and this was very useful for the contractor as well, but also the design engineers, where they also had access to the Kurloo Nest platform and could see how those new contract works were performing over time. So in the words of the client, again, typically for a project of this nature, we would have infrequent measurements by surveyors working in an extremely challenging environment. And the Kurloo technology meant that they got more knowledge around the performance of their works than they've ever had before. That gave them and their client greater certainty and confidence we are meeting the specifications for the project in a safe and accurate way. And this is, as I said, again, an example of leadership. We believe leadership and responsibility working together. This contractor looked at inventing a new way of their technology, and they've actually achieved a benefit as a result. We were actually able to reduce their costs by around 30% on this project utilising this method. So thank you. That concludes our case studies Melissa, and everyone on the call. We've got some time for some questions, if you like.
Yeah, we've got a few that have come through there, Lee. So the first question is from Jason. He's asked, what is the absolute accuracy of the unit, plus or minus millimeters?
Thanks, Jason. So absolute accuracy, Jason, is, so natively Kurloo is a relative displacement monitoring system. So basically the way Kurloo works is you install one Kurloo device in a stable location, and Kurloo then understands I suppose the displacement or change in positioning over those different points relative to that one reference point over time. Absolute accuracy is more around the positional certainty of the device, but generally, yes, we've been testing the technology, utilising for over 3 years now across many applications, and with baseline lengths, so distances between reference units and monitoring units of around 2 kilometres, we can achieve 0 to 3 millimetres in terms of its accuracy. So very highly precise. In fact, probably not replicable by conventional total station or those sorts of methods over those sorts of distances.
That's great. And the next question is from Russell. He's asked, have you had any issues with vandalism?
Very good question, Russell. It's very hard. People are very hard to control sometimes. We actually have, on a previous slide there, I think I showed you where we actually have invented a vandal-proof bracket for the Kurloo device. And this bracket has a lock on it, so it allows you to actually lock the bracket to, so you can see the lug on the back of the device there. It allows you to place a lock and a chain on the device, which stops someone removing it. Obviously, also being a positioning device, as soon as someone turns it on, we know where they'll be. But we have invented a vandal-proof bracket, the ability to lock the device and all those things to try and mitigate the impacts of vandalism.
Awesome. Jason's got another question. He's asked, what communication technologies does it rely on, mobile or radio?
Thanks for that question, Jason. Kurloo at the moment natively uses LTE, Cat1 LTE M communications. So it uses the mobile phone network to do that. It does use the LTE-M, which is a lower band frequency, so it does have a little bit more penetration than conventional voice. So at the moment, natively Kurloo does use that. However, in the new year, we will have a variant that will include a Wi-Fi or mesh type solution, which will allow Kurloo to be able to communicate its results back to the Kurloo nest in some of these more challenging areas where you don't have reliable mobile phone reception. That's and that great. Device, obviously, yeah, over time, sorry, Melissa, that device over time, if you're in an area, so that Wi-Fi mesh can either tie into your local, say if you've got a site shared with a Wi-Fi modem on it, we can either tie into that mesh, or really in extreme locations, we can install a satellite gateway and use that gateway to communicate the results of Kurloo.
Awesome. Sydney's got a question. Do you have Kurloo installed on any of the mine sites, TSF and pit slopes? If so, what sorts of results are you getting?
Sydney, we have done, as you can see on those embankments, we have done extensive amount of work, be it on an embankment or a mine or a railway. We don't really think the application's vastly different. Kurloo works in a number of environments. But in terms of mine sites themselves, we do have a site that's just commenced with us. We've only started receiving one month worth of data for a mining client. So I'm not in the position to share that with you at this point in time, but certainly Kurloo is ideally suited to the risks associated with settlement and displacement of mining applications. And as I said, we've successfully adopted Kurloo in a lot of slope stability, but also settlement applications.
Awesome. Well, that's all the questions that we've got through. If anyone has any others, we can we'll just hang here for a moment, but if not, conscious of everyone's time, so we could wrap up there. If you would like to explore Kurloo further and something that Lee's said today or shared today has inspired you, we would invite you to take the next step, which is to go ahead and book a Kurloo call. You can do that via our website, so kurloo.io/contact. You can select a time straight away in there to book a chat with Lee anytime that works for you. So thank you again so much for your time, and we hope that what you've seen here is interesting. But briefly before we go, I've just published the results of the poll, and you can see that the #1 challenge that people are saying that they're facing at the moment is the cost of installation and management, followed very closely by the availability of skilled labour and the delay in receiving results. So hopefully what we've shared with you today about Kurloo has showed you that it's been designed specifically to help overcome some of those key issues that you're facing. So thanks for your participation with that poll, and appreciate the questions that have come through. Any final thoughts, Lee?
I just thank you. We'd certainly love to hear from you. We're very interested in exploring new options, and as I said, it's an obligation-free call. I'm happy to, myself and my team here, obviously happy to talk about your site, your application, how many sensors you think are needed, what is the best way to install or get the most out of your investment. So we're certainly happy to support you, and yeah, look forward from hearing from you soon.
Great, thank you.